Okay, now we want to talk about crawling content on the Search Appliance. The first section that we had to cover was how to set up the Search Appliance as a server on the network. So you have to set up its fixed IP address, the DNS servers, and in there we'll set up an administrator's username and password that can get access to configuring the GSA. Now it's time to start crawling content and serving results. If we were just to point the user to a search appliance before crawling any content, there wouldn't be anything in the index. So all they would get back is empty results. So what we have to do is we have to describe how the GSA crawls content. And in crawling, we're talking about fetching content off of a web server. We'll send a GET request to one page, and then we'll successively follow each link down into all the documents on that web server and fetch them from the server, put them into the index, cache them, and serve results. Now this is for web content. If we're dealing with the file server, we could also point the search appliance to a URL on a file server using SMB protocol and traverse those documents. But we use the terminology crawling for web servers and traversal for file servers, because traversal is a hierarchical based directory step-down lookup. We'll also show you how to troubleshoot crawling. When we fetch content from a web server, we'll also include metadata, which could be embedded in the documents, or it could be properties of the files that are associated with the document. We'll also show you how to troubleshoot the crawling phase. So let's talk a little bit about how crawling works and then show you how to set it up on the Search Appliance. To find documents, we first have to tell the Search Appliance a URL, one URL per host server, that we want to fetch a document from a web server. And this will serve as either a sitemap or a jump page or the root page of your web server that will have links to all other documents. If there are documents that are orphaned off on their own, don't have any links to them from this start page, you'll have to either include them with their own start page or put them in a jump page, the link to them in a jump page, and then include that as a start pattern. But we will use one pattern at least per server. Next, the Search Appliance will fetch each of the start URLs and then follow all the links. It will open those documents, look for other links to documents, and include those as more links to follow. Each document will be referenced by its unique URL, and so it will count as one hit against your license. If you have a 1,000,000 document license count, you will have up to 1,000,000 documents that you can crawl and index in the Search Appliance. This continues until all documents are found in a web server, at which point the Search Appliance says, I found all the links, I'm stopping. Maybe you have a 1,000,000 document license and you only found 200,000 links on a web server, then the Search Appliance stops crawling. Now, that's for a complete crawl. There'll be changes to documents throughout time. And so what you do is you instruct the Search Appliance to recrawl the content. And the Search Appliance is smart enough to know how to recrawl the content on a given period. It sets up all of its processes and schedules recrawls based on how frequently documents are changing. We'll talk about that in a few minutes. Here's an example of one document. This is the start page, and it's on server S1. What we'll do is we'll open up that start page and we'll see two more links, to 2.html and to 3.html. Those links will be followed. GET requests will be sent to the web server. The documents 2.html and 3.html will come back to the crawler. Crawler will open those documents, look for more links, and then if they're found, they'll follow those links too. Now there's a notion of a start URL. That's the seed pattern that we want to use to at least tell the Search Appliance to first look for that document. And we have to have at least one per server. So in this example, if the web.corp.com is your web server, that could be your start pattern. It could be a specific directory down inside of the web server, or it could be a specific page that's your jump page or your sitemap. But this is an example here of where it would be the main page on your root web server. Then we'll specify follow and crawl patterns. And it could be one or more patterns for that start pattern that match to it. It could be that you set the follow and crawl pattern to web.corp.com. That means that all documents found in that web server will be included, and we will follow any links that we find there. If there's a pattern that's different, maybe it's just sales directory, where sales appears inside the directory URL path somewhere, then any documents with links found that have sales in the directory path, then they will be included. Or you could specify file types. You could say only include PDFs or HTMLs. It's up to you because you can specify any GNU regular expression for a pattern. But the point is that the following crawl patterns act as a whitelisting. They say that only include these documents if they match these patterns. If they don't match the pattern, the URL is found to CNN.com or to another company or another site that you don't own. Don't worry about it. It won't get included in the index because it's not in the following crawl patterns. You can also specify blacklists or do not crawl patterns. So web.corp.com/engineering. You could specify do not crawl patterns down here, in which case web.corp.com/engineering would not be included. If we found links into this directory, this might be sensitive information. Those documents will not be fetched and indexed. And EXEs, bins, JPEGs, these are types of documents that you may not want to include in an index. So how do we set up the crawler to use the start patterns, make the initial fetches, and get the documents and include them using follow and crawl here or do not crawl patterns here? Go to Search Appliances. On the Search Appliance, what you do is you'll use your GSA administrator that you had and point the browser to port 8000 or 8443 if you're using SSL certificates. Enter in your administrator's user ID and password and log in. Here's the home page. You'll see a list of tabs on the left. These tabs are where we're going to navigate to everything. This is a page that just when you're first getting used to the Search Appliance, it's got some of the most important links on it. But all your links are here on the side. All the crawl and index links are listed under crawl and index, and under that tab, crawl URLs is where we enter in the start patterns and the follow and crawl patterns here, and any do not crawl patterns down below. Now let's take a look at one of these examples. What I've done is I've set up a web server called Athens, and I have a number of directories under Athens root directory called Google Training. This is the root directory, and I have subdirectories under them. Now I could have just left the start pattern to point to athens.learngsa.com or athens.learngsa.com/Google Training, and that would have been great for a start pattern. It would say, if it ends in a trailing slash, it'll say get that directory, and then I would have a follow and crawl pattern. I could just have one follow and crawl pattern here for that same string, learngsa.com/Google Training. But I've chosen to go with different directories, each with its own start pattern, each with its own follow and crawl pattern. And the reason for doing this is because I don't want to have to set up 20 different servers on my training environment to demonstrate how to set up a start pattern for a server and a follow and crawl pattern for a server. We're just going to treat each directory as its own instance of a set of documents. Could be on a web server, could be in a directory. Now if I point the browser to athens.learngsa.com/Google Training, here's what I get as a page. So when I send a GET request for that start pattern, the first thing that's going to come back is a listing of all directories and all subdirectories. I could click down. Each of these represents a link now. So the Search Appliance would follow each of these links, go down to each directory, and find all the documents inside of that subdirectory. This now gives us the ability to successfully drill down and find all documents under this root directory, Google Training, right here. Now when I first set up the crawler, it's going to actually look like this. There's going to be no patterns in the start pattern, and there's no patterns in the follow and crawl. So what I'll do is I'll go out and I'll find some patterns that I want to crawl and paste them in here. When I do this, I'll save the results, and the crawler begins. It looks at each of these start patterns and sends GET requests for each of these directories, and it looks, and as it finds URLs, it checks to make sure that those URLs occur in one of these follow and crawl directories. Now the crawling is not instantaneous. It takes time to fetch documents, especially if you're in the hundreds of thousands or millions of documents. Now here I crawled and indexed, well, it looks like I found 497 documents very quickly, But as I drill down, I notice that only a few directories have been actually indexed so far. So the message here is that when you start the crawler, give it some time. Documents don't get crawled immediately. And I'll show you as we go along how we investigate whether documents are in the index or if they're still waiting to be indexed. Here are the URL patterns for all those directories that I wanted to crawl. I've already done my indexing, and so I'm going to run some search requests, like for health. And I get search results. This is on, the search page is on the port 80 for the search appliance, so all I have to do is enter in the host name. And when I run a search, when I enter that first GET request, the search appliance fills in the search page, the search parameters that define the nature of the search, which user group is sending this request, whether the documents are public or secure, or whether I'm using all the documents in the index or a subset of the documents in the index. These are parameters that get set up at the top. We'll look at search parameters in detail later. It could be, if I ran a search on this GSA 19, let's go to G19, it could be that I run a search for sloth, which is one of the terms, and I get no results yet, and the document has not been indexed yet. Okay, this is a search term for one of these URLs here that I have started to crawl under crawl and index, but the document hasn't been fully indexed yet. So I'm going to go back to the GSA where I do know where the documents are crawled. I search for medical. Here's that directory page, which has got all the links to it. Okay, so you might want to consider whether you want to show this page to users or not. There's a link here that was followed to various different documents. Here's a document to a PDF. Okay, here's a document that was an Excel spreadsheet, and here's a document that was a Word document. Now I'm serving these, I followed a search result on, and now I'm following links off of the Athens server. If I go back to my search page, I can find these other documents here in the search results. Here's the spreadsheet, and if I click on this link, it'll download the XSL. If I go to the text version, this is where the search appliance crawls that Excel file. And when it stores the Excel file in the search appliance, it doesn't store the binary version of the Excel document. It stores it converts the document to HTML and stores the text of it. Now what's useful is if you follow these text links, then you don't have to necessarily have Microsoft Word installed on your user's workstation. If they want to follow the link to the entire document, they just click on the title, and that will download that XSL document, that Excel document. Other things that are in here, there's the snippet, there's the document date. This is all similar to Google.com search. And you can configure, later on when we show you how to configure this, you can determine which of these elements gets displayed in the search results. Now here's some rules for defining your start and your follow and crawl patterns. You can add a trailing slash. This says this is a directory, so make sure that you include all documents down in here. This is very important on the follow and crawl patterns, to make sure you have that trailing slash. Not so important on the start pattern, because it might be, you can do a directory lookup normally like that. If you put the trailing slash on there, it may also look for index.html files, which is nice. So if you have an index.html in your directories that lists all the documents in the directory, that might be a good pattern to put in there, is just put the trailing slash. You can use the hash or pound symbol for comments so that you can store documentation inside of these URL patterns and group them by servers and so on. And reserved characters, we can set up regular expressions inside of these URL patterns. I go down to the do not crawl patterns and notice that there's going to be, by default, there's going to be quite a few patterns already inserted in here. Let's see if we can find some. Here are some files that end, here's the $ that shows we're ending in this character sequence. So .jpe files, .pcx files, .tiff files, .bmp files, those would be excluded from the follow and crawl. Right? It says do not crawl. here's a regular expression that prevents you from getting directories like foo, bar, and then bar again, and then bar again. So if we see repetitive patterns in web servers, we'll see a lot of documents we don't want to include. We'll go down into mini subdirectories. You can use what we call the regexp, which is a regular expression operator, and then define a GNU regular expression that limits. It could be based on number of directories, how deep in the directory structure you go, like only go 3 directories deep. It could be that you specify don't include repetitive naming of directories like foo, bar, bar, bar. And you can get quite creative with these patterns, but you'll have to check for GNU regular expression documentation to know which ones to set up. If you're going to use regular expressions, there are some characters that'll be reserved characters in GNU regular expressions, such as dot, which is also shows up in file names. So you'll precede those reserved characters by double slashes when you want to hard code them and specifically say, I'd like a dot to appear inside of this file name because it's the file extension, right? So if you define a regular expression and it has maybe .jpeg in the file, let's see if we can get one of these down here. Well, here we go. So here's a case where you're using regular expression with ignore case, so it could be with capital letters inside of here. But here we're ending in file.mdb. Dot is a reserved character in regular expression, so you'll have to precede it with 2 slashes. This is escape sequence. Don't treat the dot as a special regular expression character for any number of recurring occurrences. Use it as the dot in the file extension name. When we initially start crawling, you'll see that the number of you'll see in Crawl Diagnostics a yellow line that takes off showing you this is the Search Appliance's fetch routine that is going out and making GET requests to the web server for the URLs that we're to look up. So we start with the start pattern, we open the we fetch the document, we bring it back, we open up and looking for document links, and as more links are found, they're added to this fetching process. This happens very quickly because all it is GET request, open it up, look for links, send more GET requests, open them up, look for more links. And this takes off very quickly. The indexing phase is much more time consuming, it takes longer. What we're going to look for is when the red line approaches the yellow line. So yellow line starts to taper off as all the documents are found, and then the red indexing line catches up to it. If there's a gap between these 2 lines, that's okay. That represents documents where we had errors or documents that were in do not include patterns. What we'll typically see is a general slight progression of the yellow line that says that we're adding new content. But if we see a steady increase of the yellow line and it doesn't seem to be abating, then often what we have is something called a spider trap. If you look down this page below, ask yourself what could cause a potential problem with this page? And the answer is that this is a calendar page where there's links to successive years that just keep going and going and going and going. 2013, these pages are generated dynamically. So when the Search Appliance follows a link to 2013, then the calendar page is going to get returned for year 2013, and it's going to have a link to 2014. And then you click, the Search Appliance is going to follow a link to 2014 and continue on and on and on. So you'll need to identify where your pages are continuing to progressively find more links and put a do not crawl pattern in there to limit how deep they go into the hierarchy. Now we mentioned metadata as also searchable. So we're not only going to get the documents, we're also going to fetch metadata. Metadata is the properties or attributes that can be associated with a document that are very useful for search lookups. In HTML documents, you'll find that there's meta tags inside of the header section of the HTML document. Here we have 3 tags called generator, price, and ref date, and they have values associated with them. So search users can perform metadata search lookups. They can say, look only in these metadata fields for these specific values or partial matches. And here's the operators down here in the table that show you what we can look up. We can look for the existence of a meta tag if we use the InMeta : operator and the name of the field. So in meta generator, we'll only return documents with a generator meta tag in them. Let's take a look at how this plays out. Oops. Let's go to our document repository on the Athens server and look for documents that have meta tags. They're under the ranges directory, and here's a document like maybe banana. We'll view the source of this page. Here are the meta tags: generator, region, price. They can be text, integer, or they can be currency value based. They can be multi-valued. They can be date based. And users can run searches on these values. So we'll look for generator with, say, a partial match of PS pod. So anything that has the word, any meta tag that has generator as the name, partial value as PS pod or editor. And let's run a search. Now I'm going to run a search for sloth first. And here are the documents coming back from that directory, right? I just ran a search for this text word. Now let's look for PS pod. By default, the search appliance also does a partial lookup inside of all the meta tags associated with each document. So you can see here, if I click on this link, view the search page, source of this search page, I see generator with PS pod as a partial value match. Now if I get more specific, if the user says, well, if I only want to see documents with a partial value in that specific field, in meta generator. Well, let's take the existence case first. Here's the existence case. It says look for documents that have the existence of the generator tag. So it only returns only documents that have generator as a meta tag name associated with them. If I want to do a partial match that says only find the existence of generator tag and the partial string match of PS pod inside of those meta tags, here are the results. Okay, so if I click on, I click for more search results, notice there was some automatic filtering that occurred. What we're doing here is when we find documents in a directory, the same directory path down inside of the search inside of a web server, then certain filtering occurs called directory crowding. We'll take the two most relevant results from that directory. Here's painters, and here's painters directory. And we'll assume that because we're doing intranet search, a lot of documents coming from the same directory in a web server are going to be highly related. If we listed all these documents, there might be 100 documents in there. That would be too much. It would take up all the search results page. So we can indent them like this and only give the two most relevant results and provide a link to the users to run for the rest of the searches. Okay. Now, the ones we're looking for, notice that we got documents from painters directory as well. Now we're going to look for the ones that only have that specific, let's see, is this the right one? Let's just double check. There we go. Now if we want to look for documents that have specific, that was partial string match. Now if we want to look for editor, that was another word inside the meta tag. We also get these results. If we want to do an exact match, let's say writer equals Shaw, this says the meta tag value has to equal Shaw, nothing else. Then we only get a certain number of results, 2 results here. If we ran a search, if we looked inside the document, do a view source, here's the writer, here's the value, Shaw. And there are some other values that we can run, like range-based searches on metadata using in meta, the name of the colon, name of the field, colon, and the values, say, 2 to 5. And for regions, let's see, we don't have the region tag in here. Let's go back. In meta, region 1.3. Okay, we get the results back. Let's see how many we get for all. We get 4 results with region equal either 1, 2, or 3. These are integer-based range values. If we run it between the range 1 to 2, we only get 3 results. If we run it from the range 1 to 1, we only get 2 results. We can also perform logical operations such as OR and AND, so we can combine the in-meta search to include more than one in-meta field search. So this would be look for the term sloth and the price is equal to 500 or the region is 1. Okay? But the logical operations OR and AND have to be capitalized. The date range operator here will allow you to search for a start date and an end date on the documents, and only the documents in that range will be returned. There are some limits on metadata. There's no limit on the number of meta tags for a specific document. So you could have 100 meta tags, 1,000 meta tags, no limit. The total number of bytes for all the tags is limited to 300K. So if you have 10 tags, or let's say you have 1,000 tags, then you're going to be limited to 300 characters roughly per each tag. The total number of bytes for a specific tag is 1,500. Now we mentioned document dates. There's a date range search operator, and to perform these date range searches, the documents have to have dates assigned to them when they get indexed. And there's several locations that you can look for a document date. By default, we're going to use the last modified date returned by the web server. So under configuration, there's a section called document dates here, and we can specify one or more entries of locations to look. By default, you're going to get this pattern that says look for all documents with any slash in them. That means any document basically, and we're going to use last modified date by default. Now we'll search down this list of entries that you put in there, and the first match that occurs will win and determine where the document's going to, where the crawler is going to look for the date. It could be in the URL, it could be in the meta tag, it could be in a title, or the body, or the last modified date. So going back, here are the examples. It could be in a meta tag. Here's an example of a date that was put inside of a meta tag. So you'll have to, the administrator will have to, or whoever maintains this content has to insert those document dates there. Could be in the title, could be in the body. The standard ISO format, 4-digit year, 2-digit month, 2-digit day is the standard. That's the recommended because it's the easiest for the search appliance to find. If there's no document date found, then the document will be indexed without a date. And that means that at the bottom, those documents will appear at the bottom of date range searches, and those documents will not have a date associated with them. Dates appear in search results after about 30 minutes of processing, so it takes about 30 minutes. Once the dates are calculated, then they can appear about 30 minutes later in the document search. So let's go to search page. Here, the document dates will appear after about 30 minutes after they're indexed. Now the document date calculations only occur once a week. So if you change these document dates here, these patterns here, the document date calculation will not be recalculated for up to another 7 days. If I want to, let's say you want to add, maybe you want to have a different location for documents in this directory. You could specify, let's look for them in the meta tag. Let's keep the last modified date for all other documents. This is your catch-all expression here. So make sure that's the last entry in the list. We're going to go from top to bottom. First hit wins. So most specific at the top, least specific at the bottom. And it may be that it's in the ref date meta tag. And you can specify a format here. You can also click on this help link to find out what are all the formats that are looked up by default by the search appliance. And there's quite a few you can see here. So these search appliance will look in the ref date meta tag and look for a pattern match here. If it finds one it'll use that, unless you specify exactly the format that you want. Recrawling and scheduling on the load on your hosts, your web servers. So the search appliance by default, when it first goes out and fetches documents from the web server, it will set the recrawl period to 3 days, and it will refetch the document and check to see if there are any changes after 3 days. If the document has changed, then the last modified date coming back from the web server should be a newer date than the last time it was crawled. Search appliance recognizes the last modified date, says, oh, this document's changed, so not only will I re-index that content, but I'll also reset the recrawl period to be 50% shorter the next time around. So in a day and a half, I'll crawl this content. Makes another recrawl out to the document after a day and a half. If it sees that the document, the last modified date has changed again, then it will also shorten that recrawl period by a half again, and now it will recrawl the content after 3/4 of a day. So the recrawl, as the document keeps changing, the recrawl frequency shortens, and we'll shorten it by 50% until the document comes back and it shows it hasn't changed since the last recrawl. And then we stop and say, oh, okay, it hasn't changed, so then we'll lengthen the recrawl frequency by 50%. And so it finds this medium ground here that tries to recrawl the document as often as it's getting changed. It's not a guarantee. So you'll have to do you might want to do some checking on documents. If you have documents that are changing, let's say every 15 minutes, on average, the search appliance will calculate on average, and then that it's changing every 15 minutes, and then it will recrawl the document twice as frequently on average as the document is changing. In addition to the last modified date, we'll also use a checksum. So we'll not only look at the last modified date, which might be coming back incorrectly, we'll also look at the checksum of that document, and it will determine if there's any changes to the document content, even though the last modified date didn't get changed. So those two factors, last modified date, checksum, they determine whether a change has occurred. The search appliance, if it finds a change, it re-indexes the content and shortens the recrawl frequency. Now, when documents get removed from the web server, how do they get removed from the index? Well, you could set it to be immediate, or you could set some successive retries to go out and try and fetch the document. It might have been that the web server is just not returning the file found. Maybe the web server is having an issue. Maybe the link was temporarily moved. Maybe the document is in transition in some way and returning 404s. So the search appliance doesn't assume the document's gone. You can set up retries. Let's see how we do this. We can go to the crawl schedule, and here's a checkbox that says use the default retry frequencies. If you uncheck this, you now can specify which HTTP response comes back, and there's a whole host of them, like 404s, 401s, 403s, DNS failures, and so on. Let's just pick the most obvious, 404 not found. We could choose to immediate index removal. That means that the very first time it's encountered, it will remove it. If you uncheck this, then you can specify the retry, the number of retries, and the periods of the retries. So every 24, 72, or 168 hours, and then if it's still not found, the document gets removed from the index. There are also ways to remove the document immediately from the index by going and telling the search appliance to recrawl that pattern immediately. And this is found under freshness tuning. So you can go to freshness tuning, and here's where you can specify some hints to the crawler. If you specify documents that are changing very frequently and you want to even have them crawl even more frequently than just the standard recrawl calculation, then you can enter them here. And I have a document that's changing every 15 minutes. So let's go to Athens and take a look at that page. Under GSA directory, here's a document that is dynamically generated every 15 minutes on my web server, and it will put a timestamp in with the system time at that time that document was created. So this is when the last document was refreshed. It was refreshed at 1830, and the search term is thank you that you can always look up. And let's look in here. This tells us to recrawl it more frequently than we would normally recrawl it. Let's go to crawl status and reports and crawl diagnostics, and you can see where all the history of the document that's getting crawled. And I'll drill down to its directory. And here we'll see the crawl history. The last time it was fetched was at 3:36, and it was unchanged. Now this is the GSA timestamp here. Okay, so you just have to be aware that it might be out of sync with you. You might not be getting the same time sync on your web servers. Let's just double check what the time was on this one. It was at 1830, so it looks like I'll have to do a little bit of checking here to see if my NTP time server is in sync, if I'm using the same time on the web server as I am on the GSA. Before that, 6 minutes earlier, the document had changed. So we recrawled and refetched it and reindexed it. And this is the most current version, so that's the one that's being served. Let's go and look at, run a search for a thank you. And here it is, 1830 is the system time. So it looks like my minutes are in sync, but my hours are out of sync on the web server. No big deal. But the important thing is that we're seeing the crawl history, and it's occurring about twice as fast, about every 5 to 12 minutes, twice as fast as the document is changing. So we know we're getting a good refresh on the document. For testing purposes, to see if that document is what the current version is, you can go to the link of the document, and here it goes out to the Athens server, gets the most current version. You might see that the document has changed, but it hasn't been recrawled necessarily. And you go to the cache link. This is the search document. This is the HTML document stored in the GSA's index, and it's, as you can see, the link points to GSA, and it's an HTML doc. Now let's go back to the freshness tuning and look at some of the other changes we can add. You could say crawl this pattern less frequently. Now what this will do is it'll indicate to the search appliance that this document doesn't change very often. It's an archive document, so only recrawl it every 90 days. Okay? That's a fixed rule. You can always recrawl the document whenever it's searched. So in this case, even if the checksum comes back the same and the last modified date comes back the same, we'll still force a recrawl and a reindex. You might want to do that if you have maybe announcements going out to your public on product announcements and product releases. You want to make sure that whatever the most current document is, whatever it is out there, make sure you just fetch and reindex it, just to be sure. You can also specify to recrawl a pattern. So this will say go out and do a manual fetch and recrawl right now. So I'm going to put that in. I'm going to save the change or recrawl it. And let's go out to the crawl diagnostics and see what happened with that pattern. Okay, so the crawler is a little slow. Even though we told it to recrawl right away, it still hasn't gone out. It did send a manual fetch on that document. Let's do something else. Let's use Realtime Diagnostics and search for a specific URL. Oh, let's go back to crawl diagnostics. Let's see. Let's get that specific URL and run a fetch on it. The real-time diagnostics are useful for troubleshooting. So why did the GSA crawl or not crawl a specific document? So here's the URL. Okay. I might have some spaces in there, so that might the best way to get it is up here. And this says perform a manual fetch, and the crawler just simulates getting the document. So there's no problem with the crawler finding it. It sent a GET request out to the Athens server. It found the document and got 200 OK. If there was a problem, we would see some type of an error, like maybe a 401 or a 404 error. Let's go back, crawl diagnostics, enter in the pattern that we want to check in the index here. And, well, we should see it eventually here showing up. There's also a recrawl link that's for fetching a specific document. You can also do a recrawl this URL up here. There's a link directly right there. And there we go. So the freshness tuning doesn't behave just as quickly. The quicker way to do it is inside the crawl diagnostics. You just saw that, recrawl this URL, and it sends a fetch request out to the Athens server to get the latest version of the document right now. It didn't change. The content was still the same. Last modified date returned the same. Checksum returned the same. So it didn't actually re-index it. It just refetched it. We can also specify host load settings, so we can throttle the traffic from our web servers. We can specify the number of URLs to crawl, the maximum file sizes to look at. So if a document is greater than a maximum file size, we don't include it in the crawl, we just skip it. We can also specify server load, so how many connections simultaneously can be open to a web server, and we can specify blackout periods. Some general tips on this. Here's what it looks like. Specify the number of connections that are simultaneously open per minute, and you start with 4 and increase gradually. So let's go to host load settings under crawl and index. Under host load schedule. Here's the maximum file sizes. So for TXT and HTML documents, we will not crawl and index documents larger than 20 megabytes. That's a pretty large text or HTML file. Any documents that are, other documents that are binaries, TIFFs, Word documents, PowerPoints, PDFs, 100 megabytes, that's pretty large. So anything that we don't, anything that's larger than 100 megabytes in this case, we don't want to index. If you want to increase this, you can increase this up to a gigabyte. You can also specify the maximum number of URLs. So if you want to limit your crawlers, if you want to limit your crawler to 500,000 documents, you could. That'll be set as the new floor as opposed to your license limit. By default, all servers will be searched with 4 connections open simultaneously per minute on average. Now, in this case, I reduced it down to 1 because I didn't want to overwhelm my servers. You can also specify exceptions. So I've identified an additional host for these hosts here. These are SharePoint servers. I'll only establish, on average, a half a connection a minute. So that's actually only establish a connection every 2 minutes. And I can specify the time range. 12 a.m. to 12 a.m. is 24 hours around the clock. If I want to limit it to just a 3-hour window, I could say 12 a.m. to 3 a.m. And I can specify additional exceptions down here. Now there's some reasons why URLs may not be crawled, may not be fetched and stored in the index. We mentioned that the maximum file size is greater than the setting that we put into the crawler schedule. Unsupported file types. Let's take a look at, let's go to the main documentation page on developers.google.com. This is where the documentation of the search appliance resides. And the way that you read this table is go down the left column, and these are the documents you want to read first. Okay, and setting up administration of crawl, serve, secure results, enabling Windows integrated authentication, and so on, and integration and working with connectors. But then down here, start over here, this is where you get into development. There's more work here, and there's reference information. These actually are some of the most commonly referred to documents, but they're for reference. Here's the file type formats. By default, the search appliance will crawl, index, and convert approximately 200 file types into HTML. Okay, if the document is not on this list, we don't have a converter for it to convert it to HTML, then we won't index it. You have an option that you can go with to use a feed. That's something that you develop, and you write your own converter and then send the document to the search appliance on a known port. And we'll get into feeds later on in more detail. Files beyond the license or coverage limit. So coverage limit is specified under coverage tuning. Here you can specify for a given URL pattern, like maybe Athens is the server. And maybe you only want to crawl up to 1,000 documents off that server. You can specify what we call coverage limits. Okay, you get to 1,000 documents, the search appliance is going to find the first 1,000 links, and then it's going to stop. It's not going to crawl the rest of the content, so it's a way of limiting the amount of content coming from a specific server. If you specify do not crawl pattern, the search appliance will skip the documents. So let's look over here. We talked about this earlier. Here are the do not crawl patterns. So directories containing underscore catalogs will not be included in the index. So if a user calls up and says, hey, I'm not seeing a search result in the search page like I think I would, you can come in. First thing you do is like run a test on your browser. Well, we'll show the steps in a minute. It might not be in the index due to one of these many reasons here. Files blocked by Robots.txt. A Robots.txt file is a file that a web server administrator configures and tells the web server, if you receive crawler requests from specific crawlers, don't return the content. And this is a way of throttling the traffic that comes to a web server. There's lots of crawlers out there that may come to your web servers and and it may overwhelm your server. So the administrator sets up these patterns, says in this case, here's a rule. It says user agent is star. That means any crawler agent, and every time a crawler comes to your web server, it presents an agent name. For all crawler agents, do not give them access to this directory called protected. It may be that there's secure documents there. You don't want crawlers to crawl it. If this specific crawler comes to our website, we're not going to let it get access to any of our web servers. Maybe this is a phishing scam or something. So let's go to Athens. We'll go down to the protected directory. We saw this before. Using just a web server, we can go down and view this content, right? We have access to it because it's not a crawler going to this. Now if we go to the GSA, we've included the protected directory, but let's go to the crawl diagnostics and see what happened. There's a Robots.txt blocking that. So we go to status and reports, crawl diagnostics, and drill down. And protected. Notice that we have some exclusions here. What happened? We were disallowed by Robots.txt file. If you find these errors and you want those documents included, you have to contact the web administrator, tell them to modify the Robots.txt file to allow your crawler to have access. To find out the name of your crawler, go to, let's see, HTTP headers, and here's the name of the crawler agent, GSA-crawler, and you can change this name. And there's some additional HTTP headers that you can specify for the crawler to look up. We mentioned orphan files, files that have no links to them. They will not be found by the search appliance because there's no links going from your start page down to that document. So what do? You set up a jump page or a sitemap, make sure that all those documents are listed. Archived or password protected files before 7.0, version 7.0, those documents will not be indexed, but 7.0 they will be included. You'll have password protected files, you'll have to set up crawler credentials for each of those documents. So you might have to bundle your documents using the same username and a password, or you're going to have to enter in a lot of crawler credentials into the admin console. Content or links in AJAX or external JavaScript. We will not include links to AJAX and external JavaScript. So if you have a reference inside of a document to an external JavaScript, that will not be called. But if it's internal JavaScript, we will find the links inside of there and include and index them. If you're using frame sets, you have to use properly formatted frame setting by putting the frame or anchor tag inside the frame set. If you don't, it won't be indexed. There's also a third-party vendor that supports an archiving feed, And what you do is you go to the marketplace to look for the feed, and we'll show you how to get access to feeds and marketplace later on. So to troubleshoot a URL, if it's not in the search results, user calls up, says, "I don't see a search the search result in my web server in the search results." Why not? Well, check the browser access. Make sure that it's not a restricted document. If I go to Athens restricted, this is a directory that has HTTP basic protocol security access set up on it. And a viewer, if they point their browser to it, they're going to have to enter in credentials just to see the document. All right? Now I can see the document. Well, the search appliance will also, if it's going to crawl that document, it's going to also have to provide credentials to the crawler in order to get the document. Well, in this case, we didn't set up crawler access. Crawler access is set up here. We'll talk about security in more detail. You would specify the URL pattern, the username. This is a super user that an Uber user that has read permission to all the content in that directory, and present their ID and password, and save that crawler access. Now, the search appliance, this will take a minute for this to save. The search appliance's crawler did not crawl that content. It got it already tried to crawl that content and got a 401 error. Let's go to Status and Reports, Crawl Diagnostics. We'll drill down. We'll go to Restricted. Where's, let's see. No, I didn't actually put it in. Okay. So if I hadn't put the directory in, or if I had put the directory in but not the crawler credentials, I would have gotten a 401 error. By putting in crawler credentials, it doesn't tell the search appliance to recrawl the content. So I have to actually issue a recrawl request on that in order to get it. Let's go back to crawl and index. If I were to, let's see, if I were to try and check to see why this isn't in the index, I could go to Realtime Diagnostics. Restricted, secure A, restricted -1.html, send a return. All right, I get a 401 authentication required. Okay. Oops. Let's go down. And the search appliance sends another GET request, and it got success OK, because it used the proper crawler access credentials. If I hadn't had the credentials, I would have seen 401 failure. So check the crawl diagnostics to see if the document's, first check your browser access, see if you got access to the document. Then check crawl diagnostics to see if it's in the index. If it's not in the index, run real-time diagnostics to see why it's not in the index. Check the cached version and the search results to make sure that the cached version is the way to tell that the document is actually returned and in the index and can be returned. So let's go out to, let's go to the documents under crawl diagnostics. Drill down to a document for just for hoo-ha example here. And under health, under Excel, here's a document. It's been crawled a number of times, so we know it's in the index. If I click on a cache link, it's going to show me, yes, the document has been found, it's been indexed, it's been cached. That's the last step in the indexing process. If there's not if you click on this cache link and the document's not returning anything here, you get an authorization challenge, then it means that the document hasn't been indexed yet fully. And I can run a search for my documents, and if it doesn't show up in here, then I know I have a serving problem and there might be something else. We'll talk about some of the other things later on. There's just a couple more items, but not many. There's also two search operators here, info and link, that you can use to test to see if the document's in the index. Let's go back to crawl diagnostics. Let's get this URL to this specific document. We'll run a search for info, and this says if the this says look for that document in the index. If it's there, return it. So you only get, for each specific URL, you get only one result. If it's not showing up, then it means the document's not in the index. So let's go back out here, list 2, See, no, that would indicate that that document's not in the index. We could also run the check link to see which documents link to it. Now, which document links to it? Click on that search result, and here's that jump page, which is the directory listing that had all the links. Let's see, a broken link. We hadn't talked about this. Let's look at this. This is a link on a page, but it's to a document called non-working because there is no document on the web server. We get a 404. Let's go to Crawl Diagnostics. Let's back up. Let's see what that looks like. Non-working. See, here was the link. It was found during the crawler's fetch routine, but when it tried to get the document from the server, it got 404. Okay, so that takes us through the initial configuration of the search appliance to crawl and index our content so that we can run searches and find search results. Remember that the crawling phase is the critical piece that comes after initial network configuration. You give a server an IP address and a DNS server name, then the next thing to do is come in and figure crawling. If you don't crawl any content, you're not going to have anything in your index, so you're not going to get any search results. There's, for further information, go to the documentation. After this, there may be a lab exercise for crawling. You may want to go to that. The next module to view would be the serving content so that you can see how to build up different user interfaces and experiences for different user groups. Thank you.